taps and dies are tools used to create screw threads, which is called threading. Many are cutting tools, others are forming tools. A tap is used to cut or form the female portion of the mating pair. A die is used to cut or form the male portion of the mating pair. The process of cutting or forming threads using a tap is called tapping, whereas the process using a die is called threading. Both tools can be used to clean up a thread, which is called chasing. History. While modern nuts and bolts are routinely made of metal, this was not the case in earlier ages, when woodworking tools were employed to fashion very large wooden bolts and nuts for use in winches, windmills, watermills, and flour mills of the Middle Ages. The ease of cutting and replacing wooden parts was balanced by the need to resist larger amounts of torque, and bear up against ever heavier loads of weight. As the loads grew ever heavier, bigger and stronger bolts were needed to resist breakage. Some nuts and bolts were measured by the foot a yard. This development eventually led to a complete replacement of wood parts with metal parts of an identical measure. When a wooden part broke, it usually snapped, ripped, or tore. With the splinters having been sanded off, the remaining parts were reassembled, encased in a makeshift mold of clay. A molten metal poured into the mold, so that an identical replacement could be made on the spot. Metalworking taps and dies were often made by the users during the 18th and 19th centuries, using such tools as lathes and files for the shaping, and the smithy for hardening and tempering. Thus builders of, for example, locomotives, firearms, or textile machinery were likely to make their own taps and dies. During the 19th century, the machining industries evolved greatly, and the practice of buying taps and dies from suppliers specializing in them gradually supplanted most such in-house work. Joseph Clement was one such early vendor of taps and dies. Starting in 1828, with the introduction of more advanced milling practice in the 1860s and 1870s, tasks such as cutting a tap's flutes with a hand file became a thing of the past. In the early 20th century, thread grinding practice went through significant evolution, further advancing the state-of-the-art of cutting screw threads, including those of taps and dies. During the 19th and 20th centuries, thread standardization was evolving simultaneously with the techniques of thread generation, including taps and dies. The largest tap and die company to exist in the United States was Greenfield Tap and Amp Die of Greenfield, Massachusetts. GTD was so irreplaceably vital to the Allied war effort from 1940 to 1945 that anti-aircraft guns were placed around its campus in anticipation of possible Axis air attack. The GTD brand is now a part of Whittier Products Group. Die. The die cuts a thread on a preformed cylindrical rod, which creates a male threaded piece which functions like a bolt. The die shown or top left, an older split die with top adjusting screw, bottom left, a one-piece die with top adjusting screw, center, a one-piece die with side adjusting screw, right, two dies with side adjusting screws. A cylindrical blank, which is usually slightly less than the required diameter, is machined with a taper at the threaded end. This chamfer allows the die to ease onto the blank before it cuts a sufficient thread to pull itself along. The adjusting screws allow the die to be compressed or expanded to accommodate slight variations in size due to material, manufacture, or die sharpness. Each tool is used independently, but are usually sold in paired sets of both types, 1 die and 3 taps. Some sets may provide a lesser number of taps. The common sets shown are designed for hand operation, but different types such as helical or spiral may be used in production tools such as CNC machining tools, which employ die heads to make large volumes of threaded parts. Die nuts, also known as Pre-threading dyes are dyes made for cleaning up damaged threads, have no split for resizing and are made from a hexagonal bar so that a wrench, a shift, a spanner can be used to turn them. Die nuts cannot be used to cut new threads. Lubricants. The use of a suitable lubricant is essential with most tapping and reaming operations. Recommended lubricants for some common materials are as follows: carbon steel, petroleum-based or synthetic cutting oil. Alloy steel, petroleum-based cutting oil mixed with a small amount of kerosene or mineral spirits. This mixture is also suitable for use with stainless steel. Cast iron, no lubricant. An air blast should be used to clear ships. Aluminum, kerosene or mineral spirits mixed with a small amount of petroleum-based cutting oil. In some cases, products such as WD-40, CRC 5-56 and 3-in-1 oil are acceptable substitutes. Brass, kerosene or mineral spirits. Bronze, kerosene or mineral spirits mixed with a small amount of petroleum-based cutting oil.